This is a podcast for Dr. Lewis's Differential Equations course. Today I will be talking about the methods of solving a first-order differential equation. The three methods are separable, linear, and exact. The first method is separable equations. This method is used if the right-hand side of the equation dy dx equals the function of xy can be expressed as a function of g of x that depends only on x times a function p of y that depends only on y. Here I will show you an example of a separable equation. The first thing you will do is use cross multiplication to move all the like values to one side of the equal sign while keeping the remaining like values on the other side. You will then integrate both sides of the equal sign and add c to the end of the solution on the right side of the equation. This gives you the implicit general solution. Next, to find the value of c, you will need to integrate the values from the implicit general solution. Now you will need to get c by itself. Once c is by itself, you will substitute in the values for x and y. Once you have a value for c, you will substitute it into the implicit general solution. In order to solve for y, you will take the integrated solution from the implicit general solution and get y by itself. Substitute the value for c and simplify. This will give you your explicit solution. Next, we have the methods for solving a linear equation. A linear equation could be expressed in the form ax dy over dx plus a initial xy equals bx, where a of x, a initial of x, and bx depend only on the independent variable x, not on y. The first thing you will need to do in order to solve a linear equation is to determine if it is linear or not. If it is not already linear, you can try and make it linear. Linear means that y is not with the derivative and is only raised to the first power. Next, you will need to find the value for mu and then integrate it. Once you integrate your mu, you will take that integrated factor and multiply it by the entire equation. This may require you to use the product rule once simplified. After completing the steps for the product rule, you will need to find the derivative of the function. To get your answer. Finally, I will be discussing exact differential equations. If mxy dx plus nxy dy is an exact differential form, then the equation mxy dx plus nxy dy equals 0 is an exact equation. The first thing you will need to do to solve an exact equation is identify the values for my and nx. Then you find the partial derivative of each set of values. This is used to test for exactness. Once you have finished taking the partial derivatives, if my and nx have equal values, then you know that the equation is exact. If they do not have equal values, then the equation is not exact and another solution process must be used. Since the solutions are continuous, you choose the simplest set of values within the equation and integrate them. Once fully integrated, you will need to add a g prime of x, where g prime of x is the derivative with respect to x. After you add the g prime of x, you will find the derivative of the problem with respect to x. Then you will set it equal to the remaining portion of the original equation, which is, in this case, 2xy plus 3. You will now cancel out all the like terms, which will leave you with the g prime of x equals 3. Now that you have your value for g prime of x, you will integrate it. Finally, once you have integrated the problem, you will take the equation we added the g prime of x to and substitute in the value for g prime of x. Your solution should be equal to fxy as well as c. Overall, most equations only use one method to get solved. But in some cases, you will be able to use more than just one method to solve that equation. In that case, you will need to work out the problem in the given steps and make sure that they follow along the classifications of that specific method. Through this podcast, you learned the differences between separable, linear, and exact equation. Hope it helps. Thanks for watching.